Hello everyone, welcome to this video. Today we are going to discuss about simple linear regression, and in this entire video we will talk about linear regression, how to perform it, prove the result, and also see how to implement it using Python. So this would be the steps that we are going to follow. So first of all, we'll try to see a proof of the statement and also define what simple linear regression is, what are its uses and stuff like that. And when we are done with that, when we are comfortable with the math portion of this thing, that would take a little bit of time because the math portion involves calculus, single variable calculus only, because we are doing simple linear regression. But as we go on to multiple linear regression, that would be a bit complicated. But we'll see when we get there. And after that, we'll go to apply it in Python and see how this basic ML model actually works. So this is going to be one of the first ML models I'm going to show here. Okay, so let's begin. Now, what is simple linear regression? So if you're familiar with the term regression here, it's a term that is widely used in statistics and data science. What we do here is, let's say we are given a bunch of data points, two-dimensional, let's say. So x1, comma y1, x2, comma y2, and let's say n such points are there. And these points can represent anything. So let's say the xi's, they represent students' attendance. And let's say the yi's, they represent students' final score. And for each of the n students, we have made a pair out of them. So let's say the first student has like 75% and if his score was around 60 out of 100. So these are the pairs, right? So this is our data set. Now, what would we like to do is we would like to fit this data into a straight line of the form y equals to ax plus b. And in this straight line, we would try to make the straight line such as this straight line fits them as perfectly as a straight line could do. So what do I mean by that? So if you were to plot this data right here, like this, you would see the scatter plot something like this, right? So the data would be scattered all around. And we would try to draw a straight line, maybe from the origin, maybe not from the origin, which basically is the best fit of line for this data, meaning meaning that when if you take a point and calculate the error distance from this line and you do it for all such points and each error, if you square the errors and add them up, this sum of squares error, which is also called SSE, should be the least. So this might be a little confusing, so let's actually get on to our code studio and let's see how this looks in action. Okay, so we are now in the Visual Studio. I hope you can see this. Okay. So we have a few points here. Like this is what we are going to, I have already written it down since you might need to install these things. So if you are using Visual Studio just like me, so you have to click here, go to terminal, click new terminal, and then simply paste in these things. Don't press the hash star actually. Yeah, just copy up to this if you're using a virtual environment, or you can simply basically copy from this step as well. That would also work. So when I press that, it basically says me that requirements are satisfied and it's just downloading the stats model. Okay. So you can see it's already downloading. Okay. So in order to see this action, I have already used something like this, a laptop price CSV, and I also have a salary data CSV. So for the sake of simple linear regression, we are going to do this salary data CSV thing. And we are going to explore this in detail. So how to do that? So first of all, we need to import some files. So these are the dependencies and the libraries that comes from Python, and we can use them in order to do in order to get the tools we need for data science and MLs. So import pandas as PD is the first line, and what it does is it imports a library called pandas. And Pandas data frames have all the facilities available for you to create data frames, create data, read data, export data, and also perform a lot of various options. So we are going to import Pandas, and the line as PD means we are simply going to call it PD, and Python will understand we are calling Pandas. The next one is important. We are going to import numpy as np. NumPy, think of it as as the name suggests, NumPy. So it's basically numbers in Python. So NumPy acts as a mathematical library. You could say it helps you reshape vectors, define them, make matrices, and do a lot of actions like square root, sine, cos, special functions, stuff like that. So it's like an addition with which you can do all the mathematical stuff. So pandas as in PD, NumPy as MP. And then finally, I have already written this down, so I don't have to write this again. We are going to import matplotlib.pyplot as PLT. And once you're done, just hit Shift plus Enter. This would get your code running directly, and this block of code has run. So Python has already imported all of this. So the last one, basically, it helps to display graphs. Okay. Now, how to read the data? So how to read the data is important here. So what we're going to do is we're going to create a variable named data. And as you can see, if I go to Explorer, I have this salary data here, right? So how do I read it? So there is a function called read CSV, which comes under pandas. So to access pandas, we should simply write pd dot, and you will see the read CSV function right here. Click on it. And inside, in either in double quotes or in single quotes, you can write the name directly, salary dataset dot CSV. And after that, we also want to see a glimpse of the data. So press on data head, data.head, and this is going to show you some first five data or something. So hit press enter, shift enter, and you will get the code running. And you can see our data is right here. So it is like three columns. The first one is unnamed, so it's kind of like the serial number. But these two are important: years of experience they have and the salary they have got. So this is the data we have basically. So we can close terminal for now. We don't need it. So we can try and plot this data. So you can write PLT, which I said is for plot. You can see if you write SCA, there is a function called scatter. So PLT.scatter, and we need to write some X value and some Y value. But we do not have those X and Y values yet. So what do we do? So we first define our X value. What would be the X value from this? Well, years of experience should be the independent variable and salary should be the dependent variable, right? So how do you access this column? You can simply write data and inside the third brackets, you can write years experience. But just giving this simply will not work because this is not an array yet. So what you need to do is you have to convert it into an array using np.array. So write np.array and then reshift this to -1, 1. Do it similarly for data, and then you can write salary and then reshape to -1, 1. And now we have written this, we can give the color as, let's say, blue, and then plt the show to show the graph. And you can see we have a scatter plot ready. So this is our scatter plot, right? So the data are given something like this. And now we can perform regression and we can see how the line of best fit works and stuff like that. But first we need to get to the details of how it actually works. So the math behind it is important to understand. If you want to have your basics and fundamentals strong, you need to know the math behind it always. Okay. So let's get back and see how the math works. Okay. So we are back here. So let's get to a new page. And now that we know how scatter plots and stuff like that works in Python, let's reiterate what we had said before. These are our n data sets. And now we know when we plot them on a scatter plot, they look something like this. But we want a line which kind of is the best fit line because that line would actually minimize the sum of errors from the points. So that is the best we could do with a single straight line. That is what we are going to do. So let y equals to ax plus b be the line of best fit. Line of best fit. This method is also called the least squares method, and the name is itself evident of what we are going to do. We are basically going to minimize the sum of squares, right? Okay. Now, this is if this is the predicted line, we do not know the coefficients a and b. That is what we are going to find out. They are the variables here, basically. So the entire accuracy of the line depends on the coefficients a and b. So you can put in random numbers like 1 and 2, but that would not be the best result, right? So that the a and b are the variables. So let epsilon I be the error distance from, let's say these points are also called like P1 and all the way up to Pn. So error from P1, Pi to the line L. So let this line be called L. Okay. So what should epsilon I be? So epsilon I basically should be the distance between the point yi, this, minus, we are going to subtract it from the y coordinate of the point which is on the predicted line. So on the line, if you put in xi, you will also get a corresponding value of y, which is the predicted y coordinate for that particular pi point, right? So normally the pi point has a y coordinate of yi, but it is basically of the form xi comma yi. So this is the given value. But when you put xi in our equation, that is what we are going doing basically, right? So we are predicting the values. When you put in xi, you will get a separate y value, which is the predicted y value, which lies on the line. So that is the value. And if we subtract it from this, the y value of the predicted is this. And if we subtract it from this, we get the required error in the y coordinates because that is the error the line has produced. So for every I, this is valid for every I belongs to 1 to n inclusive. Now, what we are going to do is SSE, that is the sum of the squared errors. And how do we do it? We basically sum all the n errors by squaring them. So summation I equals to 1 to n epsilon I square. In simple words, this is epsilon 1 square, epsilon 2 square, and epsilon n squared. Okay, great. So let's write this down again in simple form. So this should be summation I equals to 1 to n yi minus axi minus b whole square. And we want to minimize this SSE. Let's call this SSE as f. So f is basically the function which we want to minimize with respect to a and b, which are the variables. I think it is clear up to now. Let's go to the next page and rewrite f. F was simply summation I equals to 1 to n yi minus axi minus bi whole square. Yeah, b minus b actually, only minus b whole square. Okay. Now there are two conditions that are satisfied. Because we are trying to minimize, dou f by dou a should be 0 and dou f by dou b should be 0. That is the partial differentiation of f with respect to a. We have to calculate that and set it to 0 since we want to minimize f. And also we can do the same for dou f by dou b. That is the partial differentiation of f with respect to b. Okay, so let's start with the first one. What is dou f by dou a? So when you differentiate with respect to a, you simply get something like this, minus summation I equals to 1 to n xi whole into, and there's a 2 here because you first do the chain rule, 2 times this, and then you also find the derivative of this one using chain rule. So xy minus b, and dou f by dou b should be equal to minus 2 I equals to 1 to n yi minus axi minus b equals to 0. This is also equals to 0, right? Okay. So from the second one, let's call this equation 1 and let's call this equation 2. So from the second one, what we can do is, let's do it on the left hand side here while we still have space. So this minus 2 basically gets cancelled because there is a 0 on the other side. What we get is this summation I equals to 1 to n yi, and we can divide the summation in all three parts because since it's a summation, of course. So all of these are sums only. Axi minus summation I equals to 1 to n b equals to 0. Now, Okay, let's do it in the next page actually, because these are important terms that I need to define. So we call x bar as the mean of x, and it is defined like this: 1 by n upon x1 plus x2 all the way up to xn. So this is also some 1 by n summation I equals to 1 to n xi. In a similar fashion, y bar should be 1 by n summation I equals to 1 to n yi. Okay, let's get back to the equation we were discussing. So equation 2, we got summation I equals to 1 to n yi, and then it was minus axi. Okay, so the constant comes out. We have summation I equals to 1 to n xi minus summation I equals to 1 to n b equals to 0. Notice that this term from here is basically ny bar. So we can put that. This is ny bar minus, and similarly, this term should be a into nx bar, correct? And this term here is nothing but nb equals to 0, because the constant b is being summed n times. If you cancel n from all the equations, you get this. You get the value of b, which is y bar minus a x bar. Now let's work with equation 1. So the equation 1 was something like this. Okay, so we'll write summation I equals to 1 to n xi whole into yi minus axi minus not bi, only b, equals to 0. Break this down to get I equals to 1 to n xi yi minus summation I equals to 1 to n axi squared, right? And then minus b is constant, I equals to 1 to n xi equals to 0. Great. So we need to solve for a, right? And we already know the value of b. So what we can do here is this. We can take this term to the right hand side and write a into summation of I equals to 1 to n xi squared. And this is simply equal to summation I equals to 1 to n xi yi minus b times summation I equals to 1 to n xi. And you know the value of b already. And from this, and basically we need to divide this by this. So okay, let's write it in the next step only. I did not need the line here actually. So a should be summation I equals to 1 to n xi yi minus b times summation I equals to 1 to n xi divided by summation I equals to 1 to n xi squared, something like this. Okay. Yeah, and then you have to put in b, and then you can simplify. So anyway, so this is what we have got here. Is this is basically called the slope, and these are called the slope and the intercepts. So here a is the slope while b is the intercept. We do not need to actually do the maths here, because we will never use maths to actually find out the regulation, but we need to know it, so that when we are doing advanced algorithms in ML, there are a lot of algorithms which you have to learn after this. So like multiple linear regression is even kind of the simplest of them. Then there is logistic, and then there is a lot of stuff after regression. Classification is there. Then there are actual algorithms which can help you. Like in neural networks, you have a bunch of algorithms which depend completely on vectors and tensors, and those will really test your linear algebra skills. So yeah, you need to know the math. Okay, so let's get back to the code section and see how this works out really with the data set we have of salary. Okay, so we are back here, and up to now we have basically imported all the required libraries, and then we know how to read the data using pd.read underscore csv, this function, and we displayed the data using data.head, and then we let's actually give a comment. This is the independent variable, while this is the dependent variable. And we converted it into an array using np.array, that is a function of numpy. And then we basically did a scatter plot using x comma y, and you can also specify the color. You can also specify line where stuff like that, width and stuff, but it's okay. And then we did pld.show. Okay. Now comes the part where we are going to do the linear regression. So we need to write from sklearn dot linear model import linear regression. This is the package which we have to import from the library sklearn.linear model, and then we have to create an instance of this like this. So reg is our variable which basically will represent linear regression for us. So when you press shift enter, it basically registers all this information, and now you do have a variable called reg and you can use it to do linear regression. But let's see how. Okay, so we know that we have two variables x and y. So we simply need to fit reg.fit x comma y. We don't need to do anything. And you can see that this is as simple as it sounds. X and y have been fitted and a linear regression has been made. And if you want to see what the results of the linear regression are, you can write reg.coef, and this is the coefficients, and you can also write reg.intercept. This will give you the intercept, right? If you want to really display the let's say the equation in its terms, you can write like this: reg.coef and reg.coef, and you can take this value x plus reg.intercept. Intercept. And if you press enter, you will get the value. Okay, so this should also be 0. Yeah. Anyway, and you can also let's say truncate it to 3 decimal places if you want. So 9449.9662x plus 24848 or 204. This would be our linear regression line basically. Okay, now we also want to see it against how the line was, right? See it against the previous set of points that was plotted on the scatter plot. We want to see it in action. So how do you do that? So first we need to predict the new values. So we have a model. This is the model, and this model will given an x. This model will give a predicted value of the y values, right? So let's call a new variable y pred. So this is the predicted values of y, and we simply write reg.predict, and we predict x, right? And when you do this, ypred is done, and this will simply predict the values of x. And now what you need to do is you to first scatter the values. You need to create a scatter plot for x and y, and let's color it in red this time. Next, you need to plot the values, the lines which are going to be made, right? So the x values would be the same as before, but the y values are going to be ypred, correct? And the line, let's call it blue. And also there is a attribute called line width. This is going to be 3, let's say. And after we are done with this, we can write pld.show. And now we have a line ready, and you can see how this line basically tries to minimize the errors between the points. And this is our best line of best fit. Of course, we can improve it further, but that is due to an algorithm called trend test split. We can do that in another video. But for this video, I think this is sufficient to understand. So do practice this because you need to know the code, how to do it, and also how to do the math behind it. And also try and do it with different data sets. You can go to kaggle.com to find out different data sets, and you can maybe play around. Also, maybe try and learn multiple linear regression a bit on your own. But well, I will obviously provide a video for that as well. But for now, let's end it here. So I really hope you like this video. Just let me know in the comment section if you want more of this stuff, more on the AI and ML data stuff. Thank you.